everybody. Today we're computing probabilities in normal distributions using R in our studio. Normally distributed random variables are continuous, which means it doesn't really make sense to talk about the probability of getting any individual value back. Instead, we use a CDF, a cumulative distribution function. You feed this function an x value, and it feeds you back the probability of getting a number less than or equal to that x value just by random chance in that normal distribution. It's most clear when we see a picture. So I've labeled some x value. The shaded area represents the normal CDF, the probability of getting an x value less than or equal to that number just by random chance. One tiny bit of notation: when we're talking about the standard normal distribution n of 0, 1, we call the random variable z, and we denote the CDF with a capital Phi. So you'll see those from time to time. A lot of times we want to compute the probability that a variable with a normal distribution falls in a certain range, not just that it's less than some number. So we're going to do this by taking the probability that it's less than or equal to the top number and then subtract off the probability that it's less than or equal to the smaller number. So the shaded area on top is the shaded area on the lower left minus the shaded area on the lower right. Let's actually do some computations using a few different normal distributions and a few different probabilities. Let's switch over to R. So here we are in our studio. The only command that we're going to need right now is pnorm. Pnorm is the cumulative distribution function for the normal distribution. So to start, I'm in n of 5, 9, and I want the probability that x is less than or equal to 10. So it's just pnorm. First, you feed it the x value that you're interested in, 10. Then you need to feed it the mean, and finally the standard deviation. I said we're in n of 5, 9. The variance is 9, so the standard deviation is 3. We get 0.9522. Next, we want the probability of getting an x value greater than 10. Getting an x value less than or equal to 10 or greater than 10 are complementary events. So we can do the probability of getting x greater than 10 by subtracting off the probability, pnorm, of getting x less than or equal to 10, 10, 5, 3. And of course we get about 0.048. Next, we want to consider the normal distribution with mean 100 and variance 20. And we want the probability that x is between 92 and 95. So first of all, let's get the probability that x is less than or equal to 95. That's the upper limit. We're in a normal distribution with mean 100 and standard deviation square root of 20 because the variance is 20. So that's the probability of getting x less than or equal to 95. Now I need to subtract off the probability of getting an x value less than or equal to 92, the lower limit. So pnorm of 92, 100, square root of 20. So in this case, I get 0.095 approximately. Finally, we want to find the probability that z is between negative 1.2 and 0.1 in the standard normal distribution. So again, I take the upper limit now, 0.1. The mean is 0 and the standard deviation is 1. And I can type those in explicitly and R will do the job just like before. However, with the standard normal distribution, you can leave those out. R, if you don't feed it a mean or standard deviation, will assume that the mean is 0 and the standard deviation is 1. So pnorm of 0.1 minus pnorm of negative 1.2. Here I get 0.428.